And for those of you watching on the video, thank you for coming. And I better get started. Good afternoon, everybody. Welcome to another exciting and important afternoon of Chem 170 Organic Chemistry with your host, Dr. White. I hope you all had a nice weekend. I had fun grading labs, grading tests, this class, another class, and your extra credit projects. Those scores should all be in Blackboard. I should tell you because of the test I had to grade, and since I don't give multiple choice tests, it takes me a couple hours to do it. Uh, I fell a little behind on any of you who had uploaded past labs. By Wednesday morning, hopefully Thursday night, I'll be caught up. I'll send out any emails for anybody who's missing labs and get them in as soon as possible because the semester is just about over. Let me give you a little heads up what's happening this week and next week. Uh, Today and Wednesday, I will be, first of all, today, I'm going to go over some important information for the final exam. Then I'll go over test number 4 uh, with the answers, with the answer key. Then something I've done numerous times and it's helped students. I will be reviewing per test all the information from the semester that will help you for the final. And we'll do that today and Wednesday. Now, next Monday, a week from today, will be the final. There'll be no Zoom lecture, even though I'll show up here for a little while. If you have any questions at 1 o'clock or a little before 1 on Monday, I will send out the password for the final exam. On Sunday sometime, I'll upload it to Blackboard by Wrong School D2L, so you'll be in a position to download it and be ready. And the other thing, because of the contract with the school, the answer, Angela, yes, it will be. And for only $19.95 plus shipping and handling, I can send you an autograph copy. Not, but hopefully my videos have helped everybody. Speaking about videos, everybody, if you hear the clicking noise, give me a thumbs up. I put some ferrite cores on some of my cables to try and eliminate the problem. We'll see if it works or not. Anybody hearing that clicking now? Maybe it'll work. We'll find out. It's intermittent. If it was on all the time, I could have traced it down. But if it's intermittent, those are the hardest problems to trace down. Anyways, back to it. I'll be doing the review today and Wednesday. Next Monday, I'll give the final. You don't have to show up. Because of the contract, this has been going on for years with ECC and the faculty. Even if you give a final on the last week of class on Monday, you have a class on schedule for Wednesday, you got to show up or they can fire you. So a week from this Wednesday, you won't have to come to class, but if you want to stop by and say hello, I'll be here for about a half hour or so. And hopefully by then I'll get your grades done. All right, let's get to work. We got a lot to do. First thing I want to do is go over what's going to be on the final. Thumbs up, people. Can you see final exam information? Thank you. All right. The final will be a week from today at 1 p.m. I'll send it out. You'll have until next afternoon, 1 p.m. to take the final and upload it. This semester, I've been sort of lax on how quickly you get tests and other things in for the final because I'm under a deadline to get it done. I reserve the right to subtract up to 50 points for anybody who doesn't follow instructions or you don't upload your final by the time it's supposed to be, Tuesday afternoon, 1 p.m. Now, if you have some special circumstance, let me know in advance, and then I won't take off up to 50 points if you're late. Take as much time as you need for the final, as long as you get it in on time. If you want 3 hours, but my finals, and I've taught Chem 170 many times, most students usually need about only 90 minutes or less. Usually it's about 75, 80 minutes to finish the final. Now, the final will have 32 problems, 18 pages. Relax, take a deep breath, let it out. This final will have, yes, it's like 2 tests put together that long, but students do well on my final, especially if you pay attention this week when I do the review. I should mention what's the best way to study for the final. One, watch my review, either be here live or watch the video. And two, use your hourly exams as practice problems. Am I going to put the same problems on the test? No. On the final? No. However, if you look at my practice problems and you look at the exams for each one, they're similar. Guess what? The final will be that way too. All right. Everybody see the points breakdown on this? Thank you. I apologize for having to do that, but Zoom plays tricks on you. All right. The final will have 32 problems, 18 pages. Some of the problems are multiple part. I've never put a multiple choice question on a test or final in Chem 170. All right, points breakdown. General knowledge, 30 points. Like how many bonds to carbon? Hopefully all said 4. And nomenclature, 62 points. Reactions, 118 points. Some of the reactions, I don't know how many, but 5 or 6 maybe, if it's a handful, will be synthesis problems. And it adds up to 210 points. 210 points? Oh no, they're 10. Yes, 10. 10 bonus points on the final. Shh, don't tell anybody, Dr. White's being nice. Now, if you're curious, the points break down per material for each test. The material in test 1, there are 35 points. Material in test 2, there's 60 points. Material test 3, there's 58 points on the final. Material in test 4, 54. And new materials, amino acids and proteins, they're 4 points. Now you might want to ask, how come there's only 35 points on test number 1? Well, by now, I'm not going to ask you how many carbons are in the longest chain and problems like that, because you're already doing that for nomenclature for test 2, 3, and 4. So anyways, that's why the points, but essentially it's pretty equal breakdown of how much time I spent on what important things this semester. Now, as I have here, I recommend you download the final instructions on Sunday. You should practice by now. I think you got it, uploading a single PDF file for your from your answers. Now, if you don't have a printer, don't write out the problems. Just write out on a piece of paper your answers. Make sure you include the problem number. There will be no Zoom meeting on the 12th, the day I give the final, but the Wednesday after, optional, I have to show up. So for about a half hour or so, I'll be here on Zoom. If you want to stop by, say hello to Dr. White, feel free to. Now, well, I'll be giving it on Monday, and I have another class I'm giving a final on. I have here, I will get it done by one Sunday after the final by 1 p.m. And I'll post that score on both your final exam score, all your total points, and your final grade in D2L by Sunday. I hope to get it done by Thursday or Friday if all goes well, but you never know what could happen. I will come whatever Well, somebody gives me $1 billion and don't hold your breath on that. Get it done by Sunday, 1 p.m. Even if I got to stay up all night Saturday night, I'll get it done. Now, the final is 210 points. Relax. And historically, my students usually get about 170 to 185, 190. 180 is usually about an average. If you divide that by 2, that's same as getting a 90 average on a test, which is quite good. But then again, I don't know why. I guess I'm blessed. Thank you. I get good students. And this is both in the classroom and I'm sure online will be the same thing. You guys have been doing great during the semester. Any questions on the final exam? All right. Before I start on test number 4, problem set 1, you should have gotten an email from me personally with the points for each question you answered on test number 4. And if I made a mistake, let me know, because you should never be penalized by a mistake on a test I make. Never, never, never. Also, I will be removing test number 4 answers from this video, but if you need them, come and see me during my office hours, because this is the last week. If you have, or you can't come to my office hours, email me. We'll see if we can set up something where we can both meet, and I can set up a special Zoom meeting. That's the one nice thing about having Zoom. You know, if I were face-to-face, the only time you'd see me pre-Zoom would be when I'm at ECC, which is only Monday and Wednesday, before, during, and after class and lab. So in that way, it's helped. All right, let's get to work. Now, if you look on D2L, if you're up to date on your test, if you're missing a test, a couple you handed in later today, and I'll have to grade it today or tomorrow, you'll see not only all your test scores, but you'll see the test score sum, which is the sum of your 3 highest test scores. If you were missing a test and you handed it in, that's going to change. Now, I'm going to show you something, but I'm going to give you a warning. For the final, use the mindset, I need every point I can get. And now let's take a look at what kind of score you need on, on the final to get the grade you're looking for. Now, I have done this many times, and it usually holds true if you've handed in all your labs. I'll say this again. This is made under the assumption you've handed in all your labs, and usually if you hand in all your labs, you're going to get good lab scores. So, watch closely, because this will help you. But still, study for the final like you need every point you can get. All right, everybody see the whiteboard? And can you see x equals sum? Okay. This part I will not take out of the video. All right, X is the sum of your 3 highest test scores. Again, this is based on the assumption you've handed in all your labs. Now, Ooh, forgot something. X is the sum of your 3 highest tests plus the extra credit score. And I'll mention something about that in a second. All right, everybody see that? Now, to get an A, the number of points you need on the final is 450 minus X. To get a B, 400 minus X. To get a C, 350 minus X. And to get a D, 300 minus X. I again state that this is assuming you've handed in all of your labs. That's important, otherwise this is invalid. Let's go through a simple one. Let's assume you had 3 tests and you got 100 on each one, and you didn't hand in the extra credit, so this is equal to 300, and 450 minus 300 equal 150. And that's what you got to get on the final to get an A, the minimum. However, I'll say this in a second, now if you divide this by 2, that's the same as getting a 75 on the hourly exam, which means it's not that bad. Now, some of you are in that position. Now, here's my warning to you. I've seen this a handful of times. A student will say, oh, I only need a 75 on the final. I've been getting real good high A's, and they don't study that hard for the final. And they bomb the final. I hope you still use the term bomb the final, meaning they did stinky, real low grade. And they'll get one time, 2 letter scores below what they should have gotten. I've got a student who didn't bother studying. Oh, I don't have to. And instead of got an A, got a C. How sad. They just studied, they would have gotten their A. So even though you don't need a lot of points if you're in that position, still study like you need every point. Because if you don't study, you might do quite bad on the final. Any questions on the final? And again, final students who study, and also this week, go through my review, do well. All right, what I'll be doing today and on Wednesday, which helps my students tremendously, is I'm going to be reviewing all the material this semester. If you stick around, or if you're not here, watch the video, you'll be getting about 4, maybe almost 5 hours study time with Dr. White for the final, which only helps. Now, I'll be going through the reviews, but I'll be doing more than just that. First of all, before I go on, any questions? Is it still clicking? Hold on one second. Let me try something. Give me a second. I'm going to try another web camera, see if it makes a difference. Hang in there. I should have tried this earlier. You still hear the clicking? Is it clicking now? let's try this. That's not what I wanted to try. Clicking back. All right. Why is my one webcam, or the newer one, giving clicking? Let's do one more test. Clicking. Clicking. All right. What that tells me is I've got a problem with this webcam. It's new too. Well, let's stick with a little. That make a difference? Clicking? Still clicking? All right. Well, we'll work this out. I'm gonna, why would a webcam that's new? Ah, I have no idea. Hold on one second. I'm killing myself. Clicking? It's not clicking. Clicking? Something with the cable location. Oh no, I'm gonna fall apart. How about now? Clicking? All right, something where the location of my web camera is, for one, is still clicking. All I've done is played with, I think I know how to fix it. We'll find out, but hold on, wait a second. No, I did that so my brains didn't leak out my ears. All right, let's get to work. All right, everybody see test number 1 review. Good, thank you. Let's go through some of this and we'll be taking a break. You should know hydrocarbons, molecules with only carbon, hydrogen atoms. And when we have hydrocarbons, we have saturated hydrocarbons, molecules with only carbon, hydrogen atoms, and only carbon-carbon single bonds, and unsaturated hydrocarbons, molecules with only carbon, hydrogen atoms, and at least one carbon-carbon double or triple bond. And as you learned in fats, unsaturated fats, they have a double bond. Organic chemists do triple bonds, Mother Nature, no. Now, I will not ask on a test, what's an alkane or a cycloalkane? By now, you know how to draw that, and you know how to find the longest chain for an alkane and the key alkyl groups. By now, you've learned the alkane names, methane through decane, 5 is pentane, 7 is heptane. Go back and review it. And then the key methyl alkyl groups. Oh, look, it's your old friend, the methyl group. This thing, 6 months ago, if I had said methyl, would you even know what I'm talking about? Isn't that amazing? You should all be proud of what you've learned in my class, because most Americans, most people on this planet don't know organic chemistry. You do. And it's quite important to our daily life, as you found out this semester. All right, methyl, 1 carbon, 2 carbons, ethyl. For 3 carbons to the end carbon and propyl, center carbon, isopropyl. What you're seeing on the screen is from test number 1 review in the lecture file folder of D2L. And when it's 3 carbon center carbon isopropyl group. When you have 4 carbons, you can have to the end carbon N-butyl when it's on a chain or ring, or my favorite, I also like isopropyl too, but my favorite is the tert-butyl or T-butyl. 4 carbons, center carbon has 3 methyl groups or CH3, as center carbon is bonded to a ring or a long chain. Is it clicking yet again? Hold on, I'm going to go get some ibuprofen because I have a headache. All right. Well, it tells me it's between the camera and my USB port. Well, at least hooked it down. All right, common mistake. What's the name of that compound? Oh, that's the ugliest looking. Hold on a second. I'm having a bad ring drawing day. Let's do it better. That's better. What's the name of this compound? For a ring, every bend in the line is carbon, 6 of them, hexane, but it's a ring. Common mistake students forget to do is put cyclohexane. And if there's only one group on there, it's not numbered because every carbon, if there's only one, and I'm going to give you some fun to do. What's the IUPAC name for that molecule? Time's up. Put down your pencils and pens, hand in your computer. But anyways, what do we have? A ring. How many carbons? 1, 2, 3, 4, 5. 5 carbons. Pentane. It's a ring, cyclopentane. 1, 2, 3 carbons to the end carbon is N-propyl. Now, I have a bad habit of throwing in capitals. If you were keyboarding this, which you'll never do on my test, they would be all smaller case. There'd be no space there. Don't forget, I am not holding you to the alphabetical rule. And let's take a break. Yep, it's time to take a break. I'll be back in 5 minutes. That's 1:55. I'm going to go stretch. I also put a Band-Aid on my head because it's hurting from all this clicking, no clicking. I'll be back in 5. let's get back to work. All right, we're going through stuff from test number 1 material, and let's do one more. And the question is, what's the IUPAC name for the following molecule? Have fun. Clicking still going? I didn't touch anything in it. I think it has to do with where the cord is. Hold on. I'm going to get my handy dandy Shung Fu or whatever it is. Hopefully this will get rid of the clicking. No, but it doesn't. At least I know where the problem is. All right, I'll give you another 25 seconds. All right, let's get going. This is an alkane, and the question is, what's the longest chain? And 1, 2, 3, 4, 5, 6, 7, 8. I could also have here 5, 6. And there's one more chain you got to consider. That's 1, 2, 3, 4, 5, 6, 7. So hopefully all agree. Remember, the math was hard this semester. Got to know how to count up to 10 and know what numbers are smaller and larger from 1 to 10. 8 is the longest number. And based on that, the base name is octane. If this is the longest chain, oh, look, we have these two alkyl groups. Here's a methyl, here's an ethyl. Now, Dr. White follows the alphabetical rule. You don't. And notice the methyl is on carbon 3, and the ethyl is on carbon 4. Now, technically, there shouldn't be a space there. What I just drew is editing for close the space. But if you have a space like that, it's okay. Now, if you put down 3-methyl-4-ethyl, I'd give it, you'd be correct. Now, common mistake, and I'm telling you this so you don't make it, is students like to call the carbon of the first alkyl group 1. You can only call the N carbons 1. Now, notice if I started from this side, and 1, 2, 3, 4, 5, 6, the alkyl groups would be in 5 and 6 as opposed to 3 and 4, and you always use the lower numbers. Now, in terms of alkanes, you should know some real world uses. Where can you find alkanes in your daily life? Gasoline, propane for your barbecue, natural gas, which is methane, Vaseline, and baby oil. Now, the only reaction I gave you this semester, that first chapter, was alkanes or cycloalkanes plus oxygen give you CO2 and water. And most of you got that right on the exam. And I taught you at this point in this class, and most of the time, organic chemists do not balance equations. We're just interested in what do you make. Now, next chapter, we started getting into the good stuff. And I talked about alkenes, carbon-carbon double bond, alkynes, carbon-carbon triple bond. You should know an alkene is one pi bond, one sigma bond. Double bond, alkene, one pi bond, one sigma bond. Alkyne, two pi bonds, one sigma bond. Again, an alkyne triple bond is made up of two pi bonds, one sigma bond, and pi bonds we break like that, and sigma bonds you don't break. Now, we did nomenclature, and this is actually wrong. It should be, I can't draw on this. For a double bond, find the longest chain with both carbons double bond, name it as an alkene, drop the A on the ending, the whole thing, not just the E, and replace it with an E on the end, a number for acyclic, and in a ring, no number. And for acyclic, you also have to consider cis and trans. Oh. Remember, there's a 120-degree bond angle in double bonds, which is why I write it this way. And if we call this A and B, I assume you can all see my whiteboard. We have 4 carbons, even though they're bent like this because of the bond angle, longest chain 4 carbons, butane. It's a double bond, so that becomes butene. It's on carbon 2 either way, so it's 2-butane. And notice these 2 hydrogens are on the same line of a plane going across there, and that's cis. Cis is same side. Now, if we look at B, we have the same thing, 4 carbons. So that would be butane, double bond, butene. Now it's on carbon 2 as the first carbon, double bond, 2-butane. And notice the hydrogens are on opposite sides of this plane, and that's trans. And trans the hydrogens or other groups that are the same are opposite side. When you have 2 of the same group, hydrogen or methyl or anything else, and one of the carbons is a double bond, acyclic, you can never have cis or trans. Now, if we look at this molecule, question is, what's the IUPAC name? In a ring with no other functional groups, one of the carbons double bond has to be 1, the other has to be 2, and you number it in such a way that the alkyl groups have the lowest number 2. So 6-membered ring. Don't forget the cyclo. Oh, don't forget not touch the erase button on my pen. You have cyclo, hex, double bond, ANE becomes ENE, cyclohexene. One of the carbons has to be 1, the other has to be 2, so you don't use a number. And methyl group, which we have here, if this is 1, 2, would be 3. Now, let me show you the mistake students make. They say, I'm going to call this one 1. And they say the methyl group is 2. Wrong. The other carbon is going to be 2, 3, 4, 5, 6. So if you call this carbon 1, the methyl group is on 6. If you call this carbon 1, it's on 3. You always try and get the lowest numbers. And that's something you should know. Now, for triple bonds, you can't have a triple bond in a ring, so I'm not going to give that to you. And you can't have cis or trans because triple bonds are linear. What would be the IUPAC name for this? Remember, triple bond, ANE goes to YNE, and you need a number, which is the carbon of the triple bond closest to the end of the chain. You're the only one. Let me check. Yep. Think of it this way. You now have me for a private tutor. I'm sure everybody will be watching the videos. Let's do this. What's the longest chain? 1, 2, 3, 4, 5, 6, 7, 8, 9. Or it could be 5, 6. You don't do this chain right here because the triple bond has to be in the longest chain. And 9 carbons is no name. Drop the ANE becomes, whoops, Dr. White just made a mistake. No 9. What's the lead carbon of the double triple bond closest to the chain? 2. And carbon 4, we have an ethyl group. And that's how you name it. 4-ethyl, 2 no 9. Because if you counted from the other end, the triple bond carbons would be much higher numbers. Oh, excuse me. And like I said, triple bond, drop the A and E, not just the E, and replace a Y and E and a number. Now we start getting into the good stuff. If you have a triple bond and you react it with hydrogen and catalyst could be nickel, platinum, or palladium, you break the pi bonds and each carbon gets a hydrogen. And one of the important things I taught you at this juncture was you don't break carbon-carbon single bonds. So if I have this, I ask, give the organic product or products for the following. Remember, look for what's different. What's not a carbon-carbon single bond or carbon, or what's not a carbon or hydrogen or carbon-carbon single bond should get your attention. And notice a double bond. And the general reaction, double bond, H2 and a catalyst. And the catalyst can be nickel, which it is in this case platinum, or palladium. You break the pi bond, not the sigma. And notice if you have 4 carbons, you better end up with 4 carbons. Here are my 2 carbons with the double bond. I broke the pi bond. Each one gets a hydrogen. And I put in the rest of the hydrogens. Time out for important public service announcement from me, Dr. White. What will help you on the final exam, and trust me, I've seen it too many times. First of all, there's only 4 bonds to carbon. 4, yes, 4. I'm ambidextrous. I can do it. I can even do it with my eyes closed. Am I good or am I good? Now, I've seen on the final exam, someone have 3 bonds to carbon, and it's wrong. It's going to always be wrong. One time I saw someone put 5 bonds to carbon, and after I stopped laughing, this was on when we had face-to-face, so I had a paper, a red pen went, my eyes didn't even go through the brain. My eyes went directly to the hand, said, wrong. That's how quickly I did that after I stopped laughing. Remember, there's 4 bonds to carbon. The other thing that will help you on the final exam, do you break carbon-carbon single bonds? No. I'll say it again in slow motion. Do you break carbon-carbon single bonds? No. Remember that. That's the other thing that helps students on the final. All right, next one. If you have a double bond reactor with halogen gas X2, remember halogen can be, in this case, fluorine, chlorine, bromine, or iodine. You break the pi bond, and each carbon gets a halogen. Now, these are symmetrical addition. You're adding the same thing to both carbons. What happens when it's unsymmetrical? Well, I showed you the example, double bond plus HX, which is an acid. In this case, X is chlorine, bromine, or fluoride. Iodine, because HF fluorine is nasty, nasty, dangerous stuff. And you try never to use that. And you break the pi bond, 1 carbon gets H, the other gets X, and it follows Markov-Nikov's rule. And let's look at an example. And the question is, what's the organic product or product? And what do we have? Ooh, a double bond. And what are we reacting with? HBr, which is HX. Remember, in this case, X can be chlorine, bromine, this is a comma, or iodine. And you break the pi bond, 1 carbon gets H, the other gets X, and it follows Markov-Nikov's rule, which is the carbon with the most hydrogens gets the hydrogen, and the other carbon gets the halogen. And as I still remember decades later, my instructor taught me the rich get richer and the poor get poorer. We're talking about hydrogens. So you break carbon-carbon single bonds? No, 3 carbons. I broke the pi bond, and notice this has 2 hydrogens. This has 1 hydrogen, which is a bigger number. Hopefully you pick 2. That gets the hydrogen, the other one gets the halogen, and there are 4 bonds to carbon, so I can put in my hydrogens. You wanted to make this CH3, that's okay, and get rid of this hydrogen, but you don't have to, it's less work for you. And your turn. And when you're done, just look up. All of you out there, just look up. All right, let's do it. What do we have here? Carbon-carbon double bond. Look at a molecule, look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention. And in this ring, that should have gotten your attention. We're adding HCl, which is HX, where X equal chlorine, bromine, or iodine. You break the pi bond, one carbon gets H, the other X, and it follows Markov-Nikolson's rule, M's rule. Now, oh no, you don't see hydrogens on a ring. Well, there are 4 bonds to carbon. This carbon has 3 bonds. 4 minus 3 is 1 hydrogen. This carbon has 1, 2, 3, 4. Remember, double bond counts as 4. 4 minus 4, 0 hydrogens. You break carbon-carbon single bonds? No. So I'm going to have my ring. I'll still have my methyl group. The hydrogen will go here, but we don't show it. The halogen, in this case chlorine, will go to that carbon. And that's the product. Now, if you put the chlorine where the methyl group is and the methyl group where the chlorine, flip them, that's okay. And that's how you do rings in Markov-Nikolson's rule. Remember, Dr. White, Mother Nature love rings, students don't. And the same thing if you have a double bond, a reactor with acid and water. Now, what do we have? We have water, remember that's HOH, and what happens is you break the pi bond, one carbon gets H, the other gets OH, and it follows Markov-Nikolson's rule. The carbon with the most hydrogen gets the H, the other carbon gets the hydroxyl group. Now, let's move on to triple bonds. You have a triple bond react with hydrogen and catalyst, but now you have 2 pi bonds and you need extra hydrogen, and organic chemists do not want to balance things if we don't have to. We're lazy. So someone came up with the idea you have the bracket X, a bracket, then the letters XS, and closed bracket. That means excess, and you have all the hydrogen through the world that will react with anything hydrogen can react with. And each carbon of the triple bond, since you have 2 pi bonds, gets 2 hydrogens, and this is what happens. Same thing with halogenation, where we use excess again. And for your fun and enjoyment on this Monday, cloudy afternoon, looks like it wants to snow out there. Well, it's December, but please hold off on dreaming of a white Christmas for a while. What would be the organic product or products that are following? And when you're done, look up. All right, look for what's different. What's not a carbon-carbon single bond or carbon or hydrogen atom? Oh, look, a triple bond. Triple bond reacting with iodine, which is a halogen, an excess. Remember, in this case, X can be fluorine, chlorine, bromine, or iodine. You break the 2 pi bonds, and each carbon gets 2 halogens. You break carbon-carbon single bonds. No. So I have 5 carbons. I better end up with 5 carbons. Here are my 2 carbons of the double bond, triple bond, excuse me. I got double bond to the brain. And therefore, here are my 2 carbons, and each one gets 2 halogens, and that's iodine. And I know there's 4 bonds to carbon. I can put in the rest of the hydrogens. Next, I talked about aromatic compounds. And the first one I talked about was benzene. And benzene is a ring with 6 carbons with 3 alternating double bonds, single, double, single, double, single, double. You can write it this way, or you can use a circle. I like the first 2 ways because I just think it looks cooler. And this is benzene if you do it this way. Now, important thing. This is a mistake made on the test 1 and the final. Getting ahead of myself. If I were to draw the structure of A, 3 points each benzene, I see a student do this. And guess what? That's cyclohexane. That's wrong. You either got to do this or the other resonance form, this, or, which I don't think I like, but you can, that. And that's how you draw benzene. Be sure to make sure you remember that. And whenever you're drawing a benzene ring, don't forget the double bonds or the circle, because otherwise it's cyclohexane. I'll write it wrong, mark it wrong. All right, when there's a methyl group on a benzene ring, we don't call that methylbenzene, it's called toluene. Now, for disubstituted benzene rings, we have special name, 1,2-ortho, 1,3-meta, 1,4-para. Now, if we look at the following molecule, notice I have a benzene ring, double bonds, give that away. I have an ethyl and T-butyl. If I call one of these 1, then the other is on carbon 3, which is meta. So this would be meta. And you can write T or tert-butyl, ethyl, benzene. Now, since I'm not holding you to the alphabetical rule, if you put the ethyl first and the T-butyl second, that would be okay. Now, in toluene, the methyl group is considered a substituent on benzene, and therefore, if I had this, oops, I already did one of those. If I have this, what would be the IUPAC name for that? I'm going to let you try it and then I'll do it. While you're doing that, quick commercial from Dr. White. Don't forget to hand in all your labs. Instant replay. Don't forget to hand in all your labs. All right, looks like everybody's done. Let's do this. What do we have? Ooh, benzene ring with a methyl group, and that's toluene. Then we have here 3 carbons, center carbon, isopropyl. The I looked like it was out of place. That's better. Notice this is 1, 2, 3, 4. The methyl counts as a substituent, even though it's in the name, and therefore 1, 4. Oh, look, someone wrote on the whiteboard something helpful. 1, 4 would be para. So that would be para isopropyl toluene. In case you forgot, what's that? Paramedic. Now, when you have more than 2 groups, you use numbers. Now, at this point, I talked about new substituents, which I could have brought up earlier, but you should know Cl is a chloral group, F is fluoro, Br bromo, iodine is iodo, and new one, NO2, nitro, and that's the nitro group. If you remember, both in class and on test number 1, I asked, give the IUPAC name for the following. And that's, methyl group on a benzene, toluene. Just to remind you, 2 substituents is di on a molecule, 3 are tri. Notice we have 1, 2, 3 nitro groups. So this is trinitro, if I can spell it. Trinitrotoluene, the methyl group will always be 1 in toluene, this type 2, 4, 6. So this is 2, 4, 6 trinitrotoluene, also known as TNT, which is a trade name, or I think, and dynamite is TNT, and don't quote me on this because I might be a little off, and clay mixed together in certain ways so it doesn't explode. Because this is a liquid, is extremely shock sensitive, and you look at it cross-eyed, you can almost blow up. Don't do that. Now, unlike double bonds, aromatic rings, because the double bonds are all holding hands with the pi electrons, don't want to give up those bonds, double bonds. So you have electrophilic substitution, and that's where you replace one of the hydrogens on the benzene ring with something else. And here, if you have halogenation, halogen plus ferric trihalide, you have replace one of the hydrogens with a halogen. And I've only seen this done with chlorine and bromine, so that's why I only do it. Now, One of the things, even though we did do a lab on this, I will not, and I did not teach you about substituents on the ring are directors. They tell the incoming group where to go. And since I'm not going to teach you directors, the next reaction is the only one I can ask on the final. That is benzene ring plus nitric and sulfuric. I taught you in the lab how these react to give NO2 plus, make nitrobenzene. The only thing I can put on the final is this one, and that's benzene plus sulfur trioxide and sulfuric acid puts on a sulfonic acid group, SO3H. Common mistake, students make SO4, no such thing. So make sure you get it right. And as you learned later on, a derivative of this is used for all our detergents. And finally, the last one, this is the first one I taught you, in organic chemistry or just chemistry in general, when you can make a carbon-carbon single bond, it's something very special, very important. And that's Friedel-Crafts alkylation. If you take a benzene ring and react with alkyl chloride, X can be, for this case, bromine or chloride with aluminum trihalide, you make a carbon-carbon single bond, and the benzene ring bonds to the carbon in the R group with the halogen. I'll say it again, the benzene ring bonds to the carbon with the halogen. And why don't you try this one for your fun and enjoyment on this quickly paced Monday afternoon. All right, looks like everybody's done, so I'm going to do this. What do we have that's different? Ooh, a benzene ring. What do we have here? Remember what's not carbon, what's not high. Ooh, a chlorine. We have alkyl halide. For this reaction, X can be chlorine or bromine. And notice we have a catalyst, aluminum trihalide. And you get Friedel-Crafts alkylation. What's the R group? 3 carbons. Notice the center carbon has the halogen. So here you'll have your benzene ring. Don't forget the bonds inside, or a circle. 3 carbons. Center carbon is bonded to. Now let's have some more fun with this because Dr. White likes it. And the question is, what 2 things do I react together in the presence of aluminum tribromide to make that molecule? Have some more fun. Oh, am I sharing a lot? Hopefully you're not getting sick of me saying that. And hopefully you're seeing the benefits of watching Dr. White's review for the final. Because this way, you're going to have a couple hours studying before the final and before you get started. So it looks like everybody's done. And let's take a, ooh, what's different here? Benzene ring with an alkyl group. What are we reacting with? Aluminum trihalide. X can be bromine or chlorine. In this case, it's bromine. What do we react? Benzene plus an alkyl halide. And the carbon bonded to the benzene ring is the carbon with the halogen. Notice we have 4 carbons in that carbon, so one answer will be benzene. And we have 4 carbons, doesn't matter which end of the chain you put it on. And you have what halogen? This one. And for those who are coming in a little late, I'm doing a review for the final. Check the video, you can see what you missed. And that's how you do it. All right, any questions on this? Let's continue. Oh no, we're at the end of test number 1 material. For those who came in late, don't forget to look at D2L announcement or check your email. I have a points breakdown for the final exam, which will be a week from today. All right. Let's move on. And let's look at test number 2 material. And there we started with alcohols. And what's an alcohol? That's a carbon with a hydroxyl group. How do you name it? You find the longest chain with the carbon with the hydroxyl group, name it as an alkane or cycloalkane, drop the E and add OL. For acyclic, you need a number. When it's a ring, no number, because that carbon, when it's the only functional group, which is what I've done this semester, will be number 1. And you do the rest of the substituents the same way. So if I were to ask you, give the IUPAC name for the following molecule, have fun. Secret message to Samantha. How's Pinky?
I'm sorry, I was printing up the thing for test number 2.
Oh,
just so I could
how's Pinky? What?
Which,
Your cat.
oh, she's doing really good.
Okay.
She's napping in the corner.
I didn't see her in class today. I just wanted to check how she was doing. Because I got to check my attendance list to make sure everybody's here with their cats and dogs and other pets. Anyways, I was just playing with you. All right, let's do this. Everybody finished. I'll give you a couple extra seconds. What's the IUPAC name for the following molecule? All right, looks like is everybody done? Everybody's done. What do we have that's different? When you look at a molecule, Look for what's not carbon and what's not. Oh, an oxygen with a hydrogen. This is an alcohol. And don't forget to play that fun game when you're studying for the final. Circle and name the functional group. 2 points each. Hint. All right, longest chain. 1, 2, 3, 4, 5. This way it would be 4 that has the hydroxy group carbon. That's pentane. It's an alcohol. Drop the E, add OL. What carbon is the hydroxyl group on? Carbon 2. 2-pentanol, and carbon 3, because we're not using that numbering, is a methyl group. And that's how you do it. Now, one of the things I'm always bad at, I'm drawing structures before I write names. Why don't you draw the structure for 3N-propyl cyclohexanol? And for those who came in late, I got an email from Assistant Dean asking how I'm doing and everything, which just looked like a form email. And one of the things she sent out to everybody, I assume everybody else got it, was a list of what people are writing in their syllabus for online classes. And I was shocked to see people are putting down, you can't wear pajamas to class. Come on, you're on the internet, who cares? And you can't come to class if you're sitting in your bed. Who cares? I don't. All right, anybody need more time? All right. How do you decode the name? Start from the right, move left. OL ending, alcohol. If it was cyclohexane, 6-membered ring. Oh, that's the ugliest 6-member. I told you I was having a bad ring drawing day. You know, sort of like bad hair days. That's better. And it doesn't matter which carbon you put the hydroxy group. If this is 1, you can go clockwise or counterclockwise. Here's carbon 3 and propyl, 3 carbons and carbon. And you know there's 4 bonds to carbon. And that's how you do it. So don't forget, on the final, there'll be 2 types of nomenclature question. One, give the IUPAC name, and the other is draw the structure for the following. Now, there's certain common names that we use still today. By the way, did anybody drive by a gas station and see your gasoline, which has alkanes, also has alcohol in it? When I ask a question, give them an example of something used in your daily life with alcohol. Dr. White would put down vodka. But anyways, common names. Name the R group as an alkyl group, and then add the word alcohol. An example, isopropyl alcohol, which is in rubbing alcohol, which is good to kill the COVID-19 virus. So you should have some in your house, hopefully in case you ever need it, but it's hard to find. And time for a public service announcement. Now, how many of you have ever used the disinfectant liquid, or that's not what they call it? You know, it's in the little bottles you can buy, or big bottles, to rub your hands and it kills all the yuckies on your hand. That sounds official, like COVID-19, which is important. And usually that's gelled water using hydroxyethyl cellulose, which I taught you later how to make, and water and ethanol. Now, 2 places you can get ethanol. You can spend a lot of money and go to your local liquor store and buy Everclear, which is essentially almost 100 proof ethanol. Or if you want to save money and you're not going to drink this, you can go to your favorite home improvement store like Lowe's or Menards or Home Depot. When this started last March, that was one of the first things I did. And I wasn't the only one because they got cleaned out pretty quick after I went there. And you get the gallon, I bought a gallon one. This is still in my basement for emergencies, of denatured ethanol. And you mix that 70% or let's see, about 70% water, no, ethanol, 30% water. Yours is not going to be as thick as the stuff you buy. If you want, go to Amazon.com and get some hydroxyethyl cellulose or sodium carboxyethyl cellulose, and you can thicken up so it's a nice gel, but that will work quite well. By the way, denatured means they put something in the alcohol that if you drink it, you'll get sick and upchuck, which is why I say if you buy that, do not drink it. Now, the stuff from the liquor store, you can drink, and that's dangerous. You don't want to drink it straight. If you mix it with a Hawaiian punch, 1 cup of Hawaiian, 1 cup of Everclear to 1 cup minus a gallon of Hawaiian punch. You have Dr. White's famous lamp punch, 3540 proof, and you can't taste the alcohol. It's dangerous. Remember, you have to be 21 or older to do that. All right. How do you make alcohols? Well, we already went through this, but let's go through it again. Take a double bond reactor with acid and water. Remember, water is HOH. You break the pi bond, 1 carbon gets H, the other gets OH. And it follows Markovnikov's rule. The carbon with the most hydrogens gets the hydrogen, the other carbon double bond gets the hydroxyl group. Oh, let's have some fun with this. And this was the only reaction I put on test 1 and 2, general reaction. What would be the product or products for the following reaction? Go. All right, everybody done? All right, looks like everybody's done. When you do an organic reaction, look for what's different. What's not a carbon-carbon single bond, carbon or hydrogen atom? Ooh, double bond. What are we reacting with? Acid and water. Remember, water is HOH. Break the pi bond, and 1 carbon gets H, the other gets the OH. How do you know? It follows Markovnikov's rule. The carbon of the double bond with the most hydrogen gets the hydrogen, the other one gets the hydroxyl group. And here we have 2 and 0, which is the larger number, and time's up. Hopefully I'll pick 2. Do you break carbon-carbon single bonds? No. So I have my 3 carbons. This carbon will get the hydrogen. The other carbon, this one right here, gets the hydroxyl group. There are 4 bonds to carbon. And I've just put in my hydrogens, and you get T-butyl alcohol. Oh no, I've gone over. Let me go 3 more minutes and we'll take our 5-minute break. I want to cheat you out of your break time. All right. Reactions, no, reactions of alcohols. If you have dehydration of an alcohol, alcohol plus sulfuric acid and heat, the little triangles like the flame on top of a Bunsen burner. Sometimes I'll put 180, sometimes I won't. You lose the H and OH, form a double bond between these, and it follows Zasev's rule. And let me show you an example of Zasev's rule. If we look at this, what's different? What's not carbon? What's not? Oh, an oxygen with a hydrogen alcohol. And notice we have sulfuric acid and heat. And hydroxyl group and adjacent carbon with the hydrogen, carbon right next door with the hydrogen, lose the hydroxyl group and the hydrogen between those two carbons, you form a carbon-carbon double bond, and it follows Zasev's rule. And Zasev's rule is you get the carbon double bond molecule with the double bond that, listen carefully, has the most carbon atoms directly bonded to the carbon of the double bond. And if we look here, let's call this A and B. Both have hydrogens on there. And if we look at A, if I lose this hydroxy group and this hydrogen, I'll get this alkane. If I lose the hydroxy group and the hydrogen from B, I'll get this alkene. And if we look at A, how many carbon atoms directly bonded to the carbons of the double bond? And the answer is here, 1. Over here, we have 1, 2, 3. Which is greater, 1 or 3? And time's up. And this is what you get as your answer. Now, in real life, you get a small amount of A and mostly B, but for my class, I'm not going to ask you to do that. Everybody clear on how Zasev's rule works? And with that, let's take a break. I went a couple minutes over, but I wanted to finish this up. Come back at 3 o'clock. That's when the big hand is on the 12, or for those with digital watches, 3:00. And Dr. White's going to stretch. That's what happens when you get older. You sit too long. Let's get back to work. And Alejandro, I keep on doing that. Alondra, I apologize. You know where I picked that up? From Zorro. You don't know who Zorro is? When I was a kid, TV Zorro, and I think that was his name. I keep on doing that to you. I apologize. Did you change your name? If you look at your screen name, I know where that came from. All right. I'm going to ask a favor of both of you. After class today, could you stick around for about 2 or 3 minutes? I'm going to do a quick experiment. And I got my masking tape to recable from my webcam to the web or to my port switch and see if that makes a difference. I think it's just going somewhere and it's hitting a cable that's interfering and making that clicking. If I can get it done, I'd appreciate your help. All right, let's get back. Let's see, how do I look? Ready to go. All right, next reaction. You take an alcohol, react it with HX, where X is a halogen chlorine bromine or iodine. The carbon with the hydroxyl group is replaced with a halogen. Now, this will react if you had a double bond in there, which I won't do on the final, and therefore it comes, oh, I'm going to have to charge you extra. Is that Natalie? Or Natalia? Oh, she's hiding behind a door. All right, let me get back to work. All right, now, because of that, another reaction I showed you was if you take a alcohol and react it with thionyl chloride, then you replace the hydroxyl group with a chlorine. All right, next series of reactions. I taught you something that won't be on the test, but I used the terminology. I don't want powder blue. And this is where I taught you about our prime and our double prime, just like X, Y, Z in math. And this is a primary alcohol. And I won't ever ask this on the final, but I'll be using the terminology. And maybe in other classes you might. This is a secondary alcohol. And this is a tertiary alcohol. And you count the number count how to spell too. And just remember, primary is abbreviated this way, secondary, and tertiary, which I think I spelled wrong, is that way. It's an awful looking R. And if we look at you take a primary alcohol, oxidize it, lose hydrogen here, hydrogen there, carbon oxygen double bond, make an aldehyde. Secondary alcohol, lose hydrogen here, hydrogen there, form a carbon oxygen double bond, you get a ketone. Tertiary alcohols never react, which means I'll never put that on my final. Why? Because I never will put on a test or a final a reaction where I ask you give the organic product or products, and the answer would be no reaction. I will never do that. So don't put that down ever, because it'll always be wrong. All right, next group I talked about thiols. And that's where instead of a OH, you have SH on a carbon. An important thing about thiols is they stink, like skunk odor stink. And onions and garlic stink, but I like onions and garlic, so, but some people don't. Now, the important thing you should remember, the story I talked about dealing with the tragedy in Texas, dealing with natural gas. Andra, don't choke. Don't forget to chew before you swallow. Am I dangerous? Am I dangerous? But anyways, and Samantha, don't forget, you can bring your cat to class. And unfortunately, they had a major gas explosion because back then they didn't put thiols in natural gas. Natural gas methane has no odor. And because of that tragedy and 150 people who died, students and teachers, Texas now and the rest of the country started putting in thiols, T-butyl into natural gas. And that's what you smell when you smell natural gas. Next thing I talked about, ethers. Ethers is oxygen with 2 carbons. R groups on R and R prime. Now, I did not teach you the IUPAC, but I did teach you the common. The common is name each R group as an alkyl group and add the word ether. And what would be the common name of that molecule? Your turn. I think I mispronounced somebody's friend's name. It's Natalia, not Natalie, right? Yeah, Dr. White. Apologize from Dr. White to her, would you? And when you're done, look up. All right, what's different? Oxygen, carbons here, they're different. This is an ether. Remember, don't forget to practice that fun game, circle and name the functional groups, 2 points each. And therefore, what do we have? We have methyl, that's this R group, this is isopropyl. Ether. Now, since this is a common name, you could just as easily put isopropyl methyl ether. Now, how do you make ethers? There's only one really good way, and that's the Williamson ether synthesis. And the Williamson ether synthesis, you take an alkoxide, RO minus Na plus an alkyl halide, and you get an ether plus salt. And the oxygen bonds to the carbon in R prime that has the halogen. I'll say that slow again. The oxygen bonds to R prime carbon that has the halogen. And the question is, what 2 compounds do I react together to make these 2 molecules? Oh, look, NaCl. And I remember I have told you the story. You go out to breakfast, lunch, or dinner with a bunch of chemists, especially organic chemists. One of us will ask, will you please pass the NaCl? Even the last week of class, I can pound out awful humor. I think everybody's done. Is everybody done? Especially those with Christmas lights behind them. All right, let's take a look. What's different here? Oxygen. R group here, R prime, R, they happen to be the same. Ooh, look at this. Sodium halide, where X can be chlorine, bromine, or iodine. And this is an ether. How do you make ethers? Williamson ether synthesis. Alkoxide plus an alkyl halide. I can call this R. I can call this R prime. Therefore, my alkoxide and you don't have to show the charges, but Dr. White likes to. Is this my R prime? Notice the carbon with the bond to oxygen is the center one, isopropyl. What's my X? Look over here, it's chlorine. And that's how you'd make that compound. Now, when you look at the next thing, at first it looks like an ether, but it's not. And this is epoxides. And I only talked about one epoxide, ethylene oxide, which I'll never ask you what's the structure, but I did talk about reactions because it's an area Dr. White worked heavily in. And if you take an alcohol reacted with ethylene oxide, you'll have this molecule, and this is an ether alcohol. And if you take N moles of ethylene oxide with an alcohol, you'll get this polyether alcohol. Common mistake. Students put the hydrox group inside the bracket. Don't. And why don't you do this reaction? Have fun. Give the organic product a product. Oh no, we lost Alondra. All right, looks like everybody's done. Let's do this. What's different here? What's not a carbon? What's not hydrogen? What's not a carbon-carbon single bond? A hydroxyl group, oxygen, and we have an alcohol. What are we reacting here? Ethylene oxide. Ooh, not 1, but 6 moles of ethylene oxide. Hold on 1 second. Hold on, I just messed things up. I hate when this happens. once in a while. No, we got it. Sorry about that. Once in a while, Zoom and all the other things I have going go crash, and I have to close through the task manager, and now we can get back to where I was going. Here we have an alcohol plus N moles of ethylene oxide. And you get this polyether alcohol, where N is this number. In this case, what's R is cyclopentane ring with a methyl group. Since you don't break carbon-carbon single bonds, you get that. I get this polyether alcohol. Notice the hydroxyl group is outside of the bracket. What's N? In this case, 6. Now, one of the things I've been telling you all year is, why am I learning about this stuff? What good is this? And some research Dr. White was doing. Let's do this. Everybody see Triton X100 on your screen? All right, this is a company name for a certain product. And I was doing some research Dr. White's working on, and I found this compound has been proven to kill COVID-19 on surfaces, not in a person, but on surfaces. And what's the structure of that? This. And here you have this unusual R group, benzene ring with 1, 2, 3, 4 carbons on a chain plus 1, 2, 3, 4 dimethyls here. That's what these are. End of a line is a carbon. And here, and they give what N is. I forgot what N is, but it's obviously more than 1. And this is used and has been shown to kill COVID-19. I don't see it here. I want to say it's 4, N is 4 in this molecule, but don't quote me on that. All right, let's get back to work. Now you know why you should be studying stuff like this. All right, next thing, I started getting into my favorite area, because now you're in one of my comfort functional groups, and that's aldehyde and ketones. Now, an aldehyde is a carbonyl, double bond to oxygen, double bond to carbon with a hydrogen R group. And A ketone is carbon double bond to oxygen carbonyl with 2 R groups on it. Now, for an aldehyde, find the longest chain that has the carbonyl carbon double bond to oxygen. Remember, I asked that on test 2, what's the carbonyl group? Both drawing it and with name, carbon double bond to oxygen. But for an aldehyde, find the longest chain, name it as an alkane. You can't have an aldehyde in a ring. Drop the E, add Al, no number, because the carbonyl carbon is always number 1. Now, when R is a benzene ring, that's got a special common name, which IUPAC made the IUPAC name, and that's benzaldehyde. By the way, that's the smell responsible for almonds mostly and cherries. You smell Dr. Pepper or Amaretto, especially DiGiorno. Ooh, public service announcement. If you go to Binny's, they have now for Christmas the 1.75 liter bottle of DiGiorno Amaretto. Outstanding. But remember, you got to be over 21. And remember, the carbonyl carbon for an aldehyde is always the 1. Now, for a ketone, find the longest chain or ring with the carbonyl carbon double bond to oxygen. Name it as an alkane or cycloalkane. Drop the ENO, add ONE. If it's acyclic, you need a number that always has the lowest number closest to the end of the chain. If it's in a ring, no number. Now, common names I asked you to learn. Well, we'll get back. When you have R prime as a hydrogen in aldehyde, this is the simplest aldehyde, formaldehyde. And we talked about the dangers of formaldehyde, and also there are good points too. I used it my last patent to make a special resin for foundries. And if it's done properly, it's safe. Unfortunately, a lot of people, especially the Chinese, don't. And when R and R prime are methyl, you have acetone. And acetone is one of the 2 molecules used for nail polish remover. Again, acetone is one of the 2 molecules used for nail polish remover. Now, as I already mentioned, important, hint, important. Get the message? Carbonyl group. How do you just define that? What is a carbonyl group with words and a picture? Carbonyl group, carbon or carbon atom, double bond to oxygen or oxygen atom. Carbonyl group, writing it, carbon, double bonded to oxygen. How do you make a ketone or aldehyde? We already went through this. If you take a primary alcohol, oxidize it. Oxygen in brackets means oxidizing it. I didn't ask you to learn the different oxidizing agents, even though we did use some of those in our labs, and you get an aldehyde. Secondary alcohol, oxidized, you get a ketone. And for your fun and enjoyment on this Monday afternoon, what would be the organic product or products that are following? All right, I think everybody's done. Let's do this. What's the, oh, an alcohol. And we're oxidizing it. What kind of alcohol is in there? There's two carbons to the carbon with the hydroxyl group. Therefore, this is a secondary alcohol. We're oxidizing it. There's this hydrogen form a carbon-oxygen double bond. And in this case, it's a ketone. You don't break carbon-carbon single bonds. So I'll rewrite this. Which carbon, which is this carbon, has the alcohol, will become this carbon double bonded to oxygen. By the way, cyclic ketones makes Dr. White very happy. I'm very happy now. Now you know I'm an organic chemist. Now, another very special way of making a carbon-carbon single bond and making an aromatic ketone is Friedel-Crafts Alkylation. Acylation is our group with a carbonyl. Here we have benzene with an acid chloride. Fortunately, I didn't have enough time to talk more about acid chlorides, and aluminum trichloride. And what you form between the carbonyl here and the benzene ring, you form a carbon-carbon single bond. And this is how you make aromatic ketones. And one use for aromatic ketones is as a sunblock in your sunscreen. That's what absorbs the harmful UV radiation from the sun so you don't get skin cancer. And if you're someone with very fair skin, Dr. White doesn't, but my brother-in-law and nephew did, if they were out in the sun too much, they could get skin cancer. And one just about did. And luckily, the doctor caught it in time. You got to either protect yourself or wear sunscreen. And that's a true story. And what would be the two products you react with aluminum trichloride to make that molecule? Your turn. All right, looks like everybody's done. Let's do this. What's different? Ooh, carbonyl and a benzene ring. We have a ketone, and it's an aromatic ketone. What are we reacting it with? Well, something is reacting with aluminum chloride, trichloride. And how do you do that? Benzene ring plus this acid chloride. And what's our, this right here? So the answer is one of these. It doesn't matter which one you put first. Benzene ring. Remember, if you just write this as cyclohexane, that's wrong. Either put the circle in there or the double bonds. What's my acid chloride? R is isopropyl. And that's how you do it. Now, reactions of ketones and aldehydes, the next four reactions, the aldehyde or ketone react the same way. If I take an aldehyde or ketone, react it with one molecule of a alcohol plus acid catalyst, keep your eye on the carbonyl carbon, That's where the fun is. You break the pi bond, and the OR from here goes to the carbonyl carbon, and the H goes on the oxygen, and you get an alcohol. If R prime is hydrogen, it's an aldehyde. If it's a carbons, it's a ketone. Now, instead of one alcohol, if you do two of them, you have ketone or aldehyde plus two alcohols and acid, and now you get two OR groups on the carbon that was the carbonyl carbon. What was attached to it is still attached to it. Now, a special case, which I talked about, is if you take an aldehyde or ketone and react it with ethylene glycol, which is two alcohols in the same molecule, which is this reaction, you get this one, and here R and R are connected together. For whatever reason, students forget to put that double bond in there. And for your fun and enjoyment, what's the organic product or products for the following reactor? All right, looks like everybody's done. Am I correct? All right, what do we have here? That's, ooh, an oxygen double bonded to carbon with carbons here and here. It's a ketone. Now, it could have been an aldehyde, but it's not. Ooh, carbon with the hydroxyl group, another carbon with hydroxyl in the same molecule, and that's an alcohol. There are two of them, though. And you learn, keep your eye on the carbonyl carbon. That's where the fun is. What's attached to it, R prime or H, R double prime, then oxygen, oxygen, R, R, OR, OR. Now in this case, this is my R group, but it's attached to the other R group. So keep your eye on the carbonyl carbon. I'll call this R prime, this R double prime, and here's my R groups. And what's attached to that is still attached. And you'll have oxygen, oxygen, CH2, CH2. But do you break carbon-carbon single bonds? No. So this is still bonded together. And for some reason, students forget to put that in. Don't. Now, once you have an acetal, hemiacetal, if you take acid and water, like in your stomach, you get back the aldehyde or ketone plus the alcohol you would have used to make that hemiacetal or hemiketal. And if you take acetal or ketal and you react it with acid and water, and this is how your stomach breaks down starches, complex carbohydrates, or simple carbohydrates, you get back the aldehyde or ketone plus the alcohol you would have gotten used to make that acetal or ketal. You want to put two in there, you can, but I don't. You don't have to balance it. And why don't you try this reaction? What's the organic product or products for the vowel? I think everybody's done. So keep your eye on the carbon with something different. Oxygen here, oxygen there. There's only two cases in all of organic chemistry with a carbon with two oxygens. That's either hemiacetal, hemiketal, or acetal, ketal. And with acid and water, they both give the same products. And those products are the aldehyde or ketone you would have used to make that acetal, or in this case, hemiacetal, hemiketal, plus the alcohol you would have used to make that. And if we look here, our prime is methyl, our double prime is methyl, and our group is methyl, which means what's attached to this carbon, which is this carbon, is still there. And you get acetone. Nobody calls this 2-propanone. And the other alcohol, you get methanol or methyl alcohol, which is a common name. And that's how you do it. Now, if I look at the clock, I'm just about out of time. Best way to study for the final is to take and use your hourly exams as practice problems. And that will help you, just like the practice problems throughout the semester. Trust me, it'll work. In a normal classroom, unlike ours, I would have handed back your tests and let you keep them. This way, I haven't told you, delete all your tests. Don't use them for practice. And with that, I'm going to ask you to stick around for a minute while Dr. White tries an experiment to get rid of clicking. Is it clicking now? I'll try it on my own. I'm going to rewire something. But Alondra, could you stick around for a second? And Samantha, thank you for coming. And I'll see you on Wednesday. Don't forget to hand in your labs and everything. Okay. Oh, I forgot to do it. With that, I am going to say, gang gesund, be healthy, stay healthy. All right.